Hello guys, and welcome to today's tutorial. In today's tutorial video, we'll be solving over 10 post-UTME most repeated questions on chemistry. The first question we have today says, what is the number of moles in 44 grams of carbon dioxide? That's carbon dioxide. What is the number of moles in 44 grams of carbon dioxide? They gave us the atomic mass of carbon to be 12. They gave us the atomic mass of oxygen to be 16. We have these options. Option A says 1 mole. Option B, 2 moles. Option C, 0.5 moles. And option D, 4 moles. Let's solve this question together. Solution. Given. From the question, what were we given? They said, what is the number of moles in 44 grams? They gave us the mass of carbon dioxide, which is mass as 44 grams. The next thing we are asking the question is, what is the number of moles? So we don't know number of moles. Number of moles is unknown. So they said we should find the number of moles. Now recall that number of moles, or let's say moles, is equal to mass over molar mass. Moles is equal to mass over molar mass. That is the formula. We have our mass, but we don't know our molar mass. So recall the formula that molar mass is equal to the relative atomic mass. It's the same thing as the relative atomic mass. The molar mass for carbon dioxide is this. We have carbon from the question to be 12. 12, which is this. We have oxygen to be what? 16. And oxygen has a subscript of 2, so we say 16 times 2 plus 16 times 2. This is the same thing as 12 plus 16 times 2 will give you 32. So we have 32 here. 12 plus 32 will give us what? 44. Don't forget, the formula, the symbol or the units for molar mass is gram per mole. We have gotten the molar mass. Now we know the mass to be 44. We also know the molar mass now to be what? 44 gram per mole. We are going to substitute this into this equation to get the number of moles. When we substitute into this equation, we have moles to be equal to mass over molar mass. The mass we have from the question is what? 44 grams. All over, the molar mass we just solved for is what? 44 grams per mole. Now, if we simplify this thing further, this is the same thing as 44 gram per 44 gram divided by mole. For us to change this, for this mole to come up, this sign changes from division to multiplication. So this is the same thing as 44 by 44 gram times mole. 44 grams will take away 44 grams. 44 divided by 44 will give us what? 1. This is equal to 1. What do we have left? Mole. So this is our final answer. We have 1 mole. From the options, option A says 1 mole. Option B says 2 moles. Option C says 0.5 moles. Option D says 4 mole. The correct answer is what? Option A. Option A is the correct answer. 1 mole. For question 2 says calculate the mass of 0.5 mole of sodium hydroxide. Calculate the mass of 0.5 moles of sodium hydroxide. They gave us sodium to be 23, oxygen is 16, and hydrogen is equal to 1. We have the following options. Option A, 40 grams. Option B, 20 grams. Option C, 25 grams. And option D, 10 grams. Let's solve this together. Solution. From the question, we are given the what? The number of moles. So we have moles to be equal to what? 0.5. We have moles to be 0.5. They said we should calculate the mass. We don't know the mass. So the mass is what? Unknown. We don't know the mass. But recall the formula that mole is equal to mass all over molar mass. For the molar mass, we need to calculate. We know the mole. We have to look for the mass, which is this, but we don't know the molar mass. So we need to solve for the molar mass of sodium hydroxide. The molar mass of sodium hydroxide is this. Na, the value for Na is what? 23. Plus oxygen, the value for oxygen is what? 16. Plus hydrogen, the value of hydrogen here is what? 1. So we put it here, plus 1. This will give us 23 plus 16. 23 plus 16 will give us what? 39. 39 plus 1 will give us 40. So we have the molar mass of sodium hydroxide to be 40 grams per mole. Now we have gotten the molar mass, we substitute this value into this equation. But don't forget, we know the mole. Now we know the molar mass, but we don't know the mass. So if we make mass subject of formula here, we are going to have, when we cross multiply, we have mass is equal to mole times molar mass. This is equal to, the mole is what? 0.5 times the molar mass. The molar mass is what? 40 grams. Don't forget, this is mole. Times 40 grams per mole. This will give us what? 0.5 times 40 will give us what? 20. So you have 20 grams. This is our final answer. Because when you simplify, this is the same thing as this is our final answer. Now when you bring the question here, which of these options matches our answer? We have option B, 20. 20 is the correct answer. Question 3 says, how many molecules are in 2 moles of water? How many molecules are in 2 moles of water? They gave us Avogadro's number to be 6.02 times 10 raised to the power 23 per mole. You have the following options. Option A, 6.02 times 10 raised to the power 23. Option B, 3.01 times 10 raised to the power 23. Option C, 1.02 times 10 10 raised to the power 24. Option D, 6.02 times 10 raised to the power 24. Now let's solve. Solution. Recall in the question we are given what? Number of moles. So we have moles to be what? 2 moles of water. They also give us what? Avogadro's number. Let's denote it with A-N, which is Avogadro's number. They say it's 6.02 times 10 raised to the power 23 per mole. They say we should find what? The molecules. So molecule, we don't know it. From the question, they say how many molecules. So we don't know the molecules, the number of molecules in it. Now recall that molecule is equal to moles or number of moles times the Avogadro's number or Avogadro's constant. The number of moles we have here is what? 2 moles. So this is equal to 2 moles times the Avogadro's number, which is what? This 6.02 times 10 raised to the power 23 per mole. This will take away this. It cancels out. 2 times 6.02 times 10 raised to the power 23 will give you 1.204 times 10 raised to the power 23. It doesn't have any unit because mole here has cancelled per mole here. They go out. So this is our final answer. Let's check for the correct option. Among these 4 options here, between these 4 options, we have option C to be the correct answer. Option C is the correct answer. Question 4 here says, calculate the volume occupied by 2 moles of an ideal gas at STP. Calculate the volume occupied by 2 moles of an ideal gas at STP. STP stands for standard temperature and pressure. From the question, we are given the molar volume at STP to be 22.4 dm³ per mole. We have this option. Option A says 11.2 dm³. Option B says 44.8 dm³. Option C, we have 22.4 dm³. And option D says 33.6 dm³. So let's solve together. Given from the question, we are given the number of moles to be what? 2 moles. So we have moles to be equal to 2 moles. They also give us something again. They give us molar volume at STP to be 22.4 dm³ per mole. So we have molar volume is equal to what? 22.4 dm³ per mole. Now recall that the volume, they said we should calculate the volume because it's unknown. So we have volume here is unknown. Recall that volume is equal to moles times the molar volume. From the question, we have moles to what? 2 moles. We have 2 moles times the molar volume. You have 22.4 dm³ per mole. This will take away this. 2 times 22.4 will give us 44.8, the unit dm³. cube. This is the final answer. Now when you come to this option, option B is the correct option. It has 44.8 dm cube. The fifth question for today says, what is the molarity of a solution containing 10 grams of sodium hydroxide in 250 cm cube of solution? What is the molarity of a solution containing 10 grams of sodium hydroxide in 250 cm cube of solution? They gave us the molar mass of sodium hydroxide to be 40 grams per mole. We have these options. Now let's solve this question together. From the question, we are given the mass. We have mass to be 10 grams. They also gave us volume of the solution to be what? 250 cm cube. So we have volume to be equal to 250 cm cube. They said we should find the molarity. We don't know molarity. Molarity is unknown. But don't forget, we know that mole or number of moles is equal to mass over molar mass over molar mass. From the question, the mass they gave to us was 10 grams. So we have mass here to be 10 grams divided by the molar mass. They gave us the molar mass of sodium hydroxide to be 40 grams per mole. So we have 40 grams per mole here. This, they cancel out. 10 divided by 40, we have 0.4 mole. Don't forget, this one comes up. We have gotten the moles here. Now for molarity. Molarity is equal to moles times volume. The formula for molarity is given as moles times volume. So we have the number of moles we have here is what? 0.4 moles times the volume we have here from the question is 250 cm cube. UNIPORT is going to give us 100 moles cm cube. Now we're going to convert this from cm cube to dm cube. To convert from cm cube to dm cube, all you need to do is you have to divide by 100. Converting from cm cube to dm cube, we divide by 100. So we're going to have 100 mole cm cube to dm cube. You divide by what? By 100 to convert from cm cube to dm cube. Now 100 mole per cm cube divided by 100 will give us 1 mole per dm cube. Don't forget, we are converting from cm cube to dm cube, so we divide by 100. This will give us 1 mole per dm cube. This is our final answer. Now we come to this option. Option A is the correct answer because it has 1.0 mole per dm cube. So this is the correct answer, option A. Question C says, how many atoms are in 3 moles of magnesium? How many atoms are in 3 moles of magnesium? They gave us the Avogadro's number to be 6.02 times 10 raised to power 23 per mole. We had the options. Option A says 1.20 times 10 raised to power 23. Option B says 1.81 times 10 raised to power 24. Option C, 2.01 times 10 raised to power 24. And option D, 3.01 times 10 raised to power 23. From the question, we were given number of moles to be what? 3 moles. So we have number of moles to be equal to 3 moles. The next we have here, they gave us Avogadro's number. Let's use AN for Avogadro's number. 6.02 times 10 raised to power 23 per mole. Now, recall that number of atoms is given at number of moles times the Avogadro's number. This is the same thing as number of moles is what? 3 moles. You have 3 moles times the Avogadro's number is 6.02 times 10 raised to power 23 per mole. 3 times 6.02 times 10 raised to power 23 will give us 1.81 times 10 raised to power 24. Don't forget, moles will take away this, they will cancel out, so we are left with this. This is the final answer. The correct option for this is option B, 1.81 times 10 raised to power 24. Question 7 says, a sample of gas occupies 600 cm3 at 27 degrees Celsius. What will be its volume at 127 degrees Celsius at constant pressure? Option A, we have 400 cm3. Option B, 500 cm3. Option C, 800 cm3. And option D, 1000 cm3. Solution. From the question, we are given the initial volume of what? 600 cm3. So let's say V1 is equal to 600 cm3 at 27 degrees Celsius. So we have the first temperature. This is temperature. Is equal to what? 27 degrees Celsius. They say what will be its volume at, so we don't know the second volume, which is V2. The final volume, we don't know it. At 127 degrees Celsius. This is the second temperature, T2. 127 degrees Celsius. Now let's transform this from degrees Celsius to Kelvin. For you to convert this, you add plus 273 is a constant. You say 27 plus 273. This will give us 300 Kelvin. The same thing for T2. This will give us 127 plus 273. This will give us what? 400 Kelvin. Now recall using Boyle's law. So we're using Charles' law. We have V1 over T1 is equal to V2 over T2. We have V1, we have our T1, we have T2, but we don't have V2. So we make V2 subject of formula. When we make V2 subject of formula here, we have this to cross multiply. We have V1 T2 is equal to this multiplies this. You have V2 T1. We divide by the coefficient of V2 here, which is all over T1. This will cancel this. We're left with V2. Therefore, we have V2 to be equal V1 T2 all over T1. Our V1 is what? From the question, 600 cm cube. So we have 600 cm cube times our T2. Our T2 is what? 400 Kelvin. All divided by our T1. Our T1 is what? 300 Kelvin. Kelvin here will cancel this. They will go out. We're left with 600 cm cube times 400. It will give us 240,000 divided by 300. This is cm cube. This divided by this. (2,400) divided by 3 will give us 800 cm cube. This is our final answer. The correct option here is option C, which is 800 cm cube. Let's move on to the next question. Question 8. For question 8 says, what is the empirical formula of a compound containing 40% carbon, 67% hydrogen, and 53.3 oxygen? They gave us the atomic numbers of carbon to be 12, that of hydrogen to be 1, and that of oxygen to be 16. These are the options, option A, B, C, and D. Let's solve together the empirical formula. Solve for empirical formula, the simplest method is to create a table. We have how many elements here? Carbon, hydrogen, and what? Oxygen. So we have carbon here, hydrogen, and oxygen. You write out their percentage. The percentage that was given for carbon is what? 40. So you have 40 here. For hydrogen, you have 6.7. And for oxygen, you have 53.3. 53.3. These were the parameters given from the question. What you need to do next is to divide each of them by their atomic number or atomic mass. For carbon, the atomic mass here is what? 12 for carbon. You divide 40 by 12. Divided by 12. For hydrogen, you have 1, so you divide by what? By 1. For oxygen, you have 16. You divide 53.3 by 16. 40 divided by 12 will give you 3.33. Hydrogen here, which is 6.7 divided by 1, will give you what? 6.7. For oxygen here, 53.3 divided by 16 will give you what? 3.33. At this point here, what you do, you look for the smallest number, the smallest value here, and you divide through by the smallest value. The smallest value we have here is 3.33. If we divide by the smallest value, 3.33, we have 3.33 divided by 3.33, and this is divided by 3.33. 3.33 divided by 3.33 will give us 1. 6.7 divided by 3.33 will give us what? 2. And 3.33 divided by 3.33 will give us 1. It therefore means for carbon here, we have what? 1. For hydrogen, we have 2, and oxygen, we have 1. This value now, we'll write it out as this CHO. These are the elements: carbon, hydrogen, and oxygen. Now we'll write the subscripts, their answers below as the subscripts. This is C1, H2, and O1. This is the same thing as CH2O. This is the final answer. Now, the correct option here is option A. CH2O. This is the correct option. Question 9 says, what volume of 0.2 molar of sodium hydroxide is needed to completely neutralize 25 cm³ of 0.1 molar of hydrogen chloride? That's option A says 25 cm³, option B says 50 cm³, option C says 12.5 cm³, and option D says 10 cm³. From the question, they gave us the volume, the initial volume to be what? They gave us initial volume, which is this, V1 to be 25 cm³. They give us M1 to be what? 0.2 molar. They gave us M2 to be 0.1 molar. They said we should find the volume of this. So the V2, it's unknown. V2 is unknown. Now recall the formula. M1 V1 is equal to M2 V2. If we make V2 subject of formula, since we are looking for V2, if we make it stand alone, we have V2 is equal to M1 V1 over M2. Our M1 we have is what? 0.2 M times our V1 we have is what? 25 cm³. all divided by our M2, which is 0.1 m. This molar will take away this molar. Now 0.2 times 25 divided by 0.1 will give us 12.5 cm cube. So this is our final answer. The correct option here is option C, 12.5 cm cube. The final question for today on chemistry says, what is the percentage of nitrogen in aluminium sulfate? What is the percentage of nitrogen in aluminium sulfate? It gave us the atomic number of nitrogen to be 14, hydrogen to be 1, sulfur 32, and oxygen to be 16. We have these answers. So let's solve together. We have the molar mass. The first step is to find the molar mass of this compound, aluminium sulfate. Molar mass of aluminium sulfate, which is NH4 2SO SO4. This is equal to, nitrogen here is equal to what? This nitrogen here is 14. So we have 14 plus, the next we have is what? Hydrogen. Hydrogen is 1. 1 times 4. This is 14 plus hydrogen here is 1. 1 times 4. You close the bracket. Now, this compound here is multiplied by 2. So you times this by 2 plus Earth here is given as what? 32 plus oxygen here is 16. 16 times 4. Now this is 14 plus 4 multiplied by 2 plus, this is 32 plus 64. That's 16 times 4 will give you 64. If you sum this up, it will give you 132 grams. You have gotten this one. Now, since you have gotten this, you come for the percentage of nitrogen. You say for the percentage of nitrogen, we have, you pick nitrogen out and you divide it by the compound aluminium sulfate. For nitrogen here, we have nitrogen to be 14 divided by what? Sorry, for the percentage, don't forget, percentage you multiply by 100. This will give us, nitrogen there is 14 divided by aluminium sulfate. We have 132. So we have 132 times 100. This divided by this will give us 0.212 times 100. It will give us 21.2%. This is our final answer. Therefore, the percentage of nitrogen in aluminium sulfate is 21.2%. 2%. That is option A. So the correct option